All right, so Algebra 1, Unit 7, Lesson 16, the quadratic formula. So 16.1, it says each expression represents two numbers. Evaluate the expressions and find the two numbers. So go ahead, pause the video, and see if you can evaluate these. All right, what does number 1 mean? Okay, so go ahead and go through 1 through 4 and see if you can evaluate them. All right, so hopefully you paused it and you evaluated. Notice the plus or minus, right? So there's actually two scenarios. Does everybody agree that 49 is square root of 49 is 7? So it's 1 plus 7 or 1 minus 7, right? Because of the plus or minus. So number 1 is either 8 or negative 6. All right, so that's basically what they mean by evaluate. You should be able to do the rest. Just know you do get some interesting fractions. For example, for number 2, you have, what's 8 plus 2? 10 divided by 5, which equals 2. Or 8 minus 2, which is 6, divided by 5. So you have either 2 or you have either 6 over 5 or 6/5. All right, so go ahead and try number 3 and 4. That's totally for you to do. Okay, it's good practice. Negative 5 squared is just negative 5 times negative 5, right? And don't forget the negative is multiplying to two positives. It's still going to give you negative, okay? All right, so let's move on to 16.2. Pesky equations. So choose one equation to solve, either by rewriting it into factor form or completing the square. Let's see here. Number 1, so I'll tell you what, go ahead and pause this and see if you can try to do those. They are a bit challenging for sure, but I highly recommend that you kind of test yourself, see what you can do. Okay, so hopefully you went ahead and tried this out. I believe the quadratic formula, if you remember the quadratic formula, or well, you haven't quite gotten there yet, but if you've taken algebra before, you know quadratic formula could be used. All right, so it's up to you on how you want to solve number 1. Now, what times what, right? So factored form, it's a little difficult because you have a decimal, right? So the decimal's there. That's a little bit more interesting. So what times what gives you 1.25, but at the same time have to add up to this negative 2. That becomes pretty difficult, doesn't it? So I recommend using quadratic formula, and we'll definitely be going through this as well throughout the lessons. So A is 1 because it's 1x squared, B is negative 2, and C is negative 1.25. If you substitute it in here, you should get x equals 2.5 or x equals negative 0.5. And that makes sense if you think about it, because if you did factored form, you could have written it like this, right? And you would have seen that the negative 0.5 times the positive 2.5 would give you the negative 1.25. But if you added up, and you can see it by distribution. So if you use the distribution, you'd still get something like this. And then that times that is this. So you would have seen it there, right? Don't forget that's whole. So that's where the 2.5 or the negative 0.5. So this is the quadratic formula. That is going to be, I believe, the main idea or the main topic for this week. All right, so what about the next one? So the next one is a bit of a tough one, isn't it? Because we do have the 5 here. You could use the quadratic formula if you want. It's really up to you. We could also try grouping. So let's see here. We had 5x squared plus 9x minus 44 equaling 0, right? We could try grouping. Let's see if we can do it. You could take the 5 out of, let's see, you could take the 5x out of both. Actually, no, let's be very cautious here. We're going to tear off that 9x and rewrite it as 5x plus 4x. We're going to see if that works. Okay, so see how I kind of broke down the 9x to where we actually have two things in common with the first group. So here's the first group. They both have 5x in common, right? So you can take the 5x out. Whoa, I scrolled on accident. That was horrifyingly scary. Scroll up. Scroll up. There we go. So you can take out the 5x. And you get x plus 1 there. Sweet. What does the second group have in common? 4, right? Let's take out a negative 4. And if we do that, we get x plus 11. So, no, doesn't work. You see that? Because these two are not the same. So that wouldn't work. So go ahead and try to figure out that one. I do recommend the easiest way is using the quadratic formula. Okay, so x equals negative b, which is your 9, positive 9, plus or minus square root of b squared, which is 9 squared, minus 4ac. A is 5, c is negative 44. So ac all over 2a. All right. If you do this correctly, okay, you should get x equals negative 4 or x equals 2.2. All right, I'm going to be honest. You do have to subtract the constant to both sides before you solve number 3. And go ahead and try number 4. Okay, I want you to struggle, but eventually you'll realize the quadratic formula is the easier option. Okay, so again, here's the quadratic formula. Let's take an example. All right, so again, the letters are in order. So A is always the first number in front of the x squared. If you just see an x squared there, it's a 1x squared. So A is 1. B is your middle value, and your plus or minus, depending on the symbol, is your C value. So that's the constant. All right, so let's look at this example. All right, A is 1, B is negative 8, and C is just 15. Nice. So they say it here, don't they? Yep. Okay. You plug them in accordingly. So let's use my handy dandy highlighter. So with A, it just goes in these two parts. B goes in these two parts, and C just goes here. Okay, you plug them in accordingly, and out comes your answer. Now, fun fact, all right, if you get a nice whole number, even if it's an integer, a negative number, it also means you could have just done this a different way. You could have done it by just either factoring by grouping, or you could have done it by just rewriting it as the factored form. So for example, what times what gives you positive 15, but has to add up to a negative 8. We know that 3 times 5 will multiply to 15 and add up to 8, but they would both have to be negative in order for them to add up to a negative 8. And that's how you get the x equals 3 or the x equals 5. So notice you don't always have to use the quadratic formula, but it's really good for those factoring questions where you can't really factor it. You can't rewrite it in factored form. Completing the square becomes almost impossible, and you're really just struggling. Quadratic formula is great in those situations. It's like the one way to do it, where sometimes it might be difficult, but not as difficult if you were to not do it. You know what I mean? So it's a good little backup. So here's some more examples that we have here of how to set up the quadratic formula. I highly recommend that you try to go through these first. So go ahead and try to solve these. Number one, you could actually just factor that like normal, like you rewrite it in factored form. Because if you tried a quadratic formula, you'd get your answers. But like I said, if you get a nice whole number, positive or negative, you could have just factored it by rewriting it into factored form or completing the square. Same thing with number two. The only one that really needs, actually there's two. There are two that really need the quadratic formula, and that is 3 and 4. So I recommend you examine number 3 and 4 and realize why they are different than 1, 2, 5, and 6 in terms of needing the quadratic formula for them. All right, so that is it for the lesson. Have a beautiful day.